number 2. No special name to this. I'm just going to lay it out for you. Draw yourself a circle. This time, give it a center. Kind of important. And let's do this. Let's do this. I got an idea. Over here, I'd like you to make 2 more smaller circles. We're gonna build up to this theorem. Okay. I'd like you to put an inscribed angle here. Here. Actually, I'm going to make them the same in all these. So kind of up and to the right, Let's put it right here. All right. Check this out, folks. Hopefully this is going to make some sense for you. I'd like you to make an inscribed angle. And let's go here. Let's go. Let's say this inscribed angle. Here's the theorem. We're gonna build up to it. Stay with me, folks. Inscribed angle. Let's say that this is 50 degrees. I can't hear you. You're behind your computer. I'm behind mine. What's that intercepted arc? Please don't say 50. You gotta double it. 50 times 2 is 100 degrees. Perfect. I'd like you to keep this ray the same. But I'd like you to kind of open this angle up. I'd like you to hinge it open. So let's make the intercepted arc go right there. So this angle obviously got bigger from here to here. Let's say it is, I don't know. Let's go. 75 degrees. Let's say it opened to a 75 degree angle. 75 degrees, intercepted arc. Mental math, folks. Has to be 150 degrees for that intercepted arc. Perfect. Now let's go over here, folks. I'd like you to make this exact same ray. Trying to keep it the same. Yep. Goes to about right here. Now this time, I'd like you to make a diameter. I wish I had a ruler. Do I have a ruler anywhere? No. Okay, I'm just going to grab a notebook. It's a K notebook. I just needed a straight edge. Make a diameter, please. Okay, get that out of here. And I'd like your inscribed angle to go to the other end point of the diameter. Now, folks, here's theorem 2. But that's a question mark, by the way. What is that angle? Don't know, huh? Maybe somebody guessed it. Maybe somebody's got it. Keep in mind, I'm going to cover up the top of this circle. If that's a diameter, that means it cuts this circle in half. You know what this arc is. You know what a half a circle is. Half a circle is 180 degrees. And if this is 180 degrees, and you've got an inscribed angle that is going to this intercepted arc, which is a half circle, I mean, you can kind of tell it's a half circle because it's a diameter. Here's what the theorem says. This inscribed angle, if it goes to the points, the end points of a diameter, not only is this going to be 180 degrees, but this inscribed angle has to be a right angle. It has to be a 90 degree angle, folks. Has to. 50, 100, 75, 150. If this is 90 and it goes to a half a circle, that's got to be 180. And if you have the 180, cut it in half, you've got a right angle right here. That's the second theorem, folks. Example 3. I think I'm on example 3. Yep, example 3. I'd like you to find the measure of angle B. Circle, center. Draw a diameter. Okay, let's get this straight edge out again. Okay. Draw yourself a diameter. We have 2 half circles here. We got a semicircle, semicircle. You know that's 180. You know that's 180. It's going to be point D. Let's put B right here. Let's put apple right there. And plop C right here. I'd like you to connect C to A, C to B. I will tell you what angle B is. It's 8x minus 4. I'll even tell you what angle A is. It's x plus 4. And ladies and gentlemen, that's all I'm going to give you. That's all I'm going to give you. You're probably thinking to yourself, okay, what do I see? Mr. Kosal, here's what I see. I see a triangle. I see a triangle in the circle, and I know, because I've listened to Mr. Kosal, that every triangle adds up to 180 degrees. All the three angles of a triangle add up to 180 degrees. I could do x plus 4, one angle, plus the second angle, 8x minus 4, plus the curse swear word, just kidding, plus that third angle has to equal 180 degrees. But they didn't give us enough information, so let's do this. I'm just gonna put x right here because that's gonna represent this last angle. If you've been watching my videos, please, I've talked about this before. Don't do that. X has already been defined here and here, so don't do that. If you were just listening to me, folks, this is an inscribed angle. Angle C is an inscribed angle to the diameter. And if you know that this intercepted arc is 180 degrees, cut that in half to get the inscribed angle. That's a right angle, folks. So we got it. We've got it. First angle plus the second angle plus the third angle, right angle, 90 degrees, equals 180. Solve for x, plug it into B, we'll move on to the next problem. Oh, is it 9x? The plus 4 and the minus 4 cancel out. Plus 90 equals $1.80. Subtract 90 on both sides. I think you should get x equals 10. X equals 10, right? Subtract 90. Yeah, x equals 10. X equals 10. Plug it in. Find the measure of angle B. You want measure of angle B. Plug it in. Let's do 8 times 10 minus 4. 8 times 10 is 80. Minus 4 is 76 degrees. Couple of these in your homework. Look out for they're not going to tell you it's a right angle in the book. You know it. An inscribed angle to a diameter has to be a right angle. That's a theorem, folks. One more theorem I got for you, and it's a pretty simple one. Theorem, numeral, trace, or en français, toi. It took 3 years of French in high school, and I hated every minute of it. I still know how to count in French. That's what I remember. Theorem 3. It works with here it is, folks. Here's the circle. I don't need a center. I'd like you to make yourself a quadrilateral on the inside. So, 2, 3, 4. And connect these. 1, 2, 3. Alright. Hopefully you understand when Mr. Kosal says the word quadrilateral. Quadrilateral means it's a 1, 2, 3, 4-sided shape. This only works for quadrilaterals. Let's call that L, M, N, K. Now here's what the theorem says. I'm not going to write it down. I'm going to make it very, very easy. Basically, this theorem says that if you have a quadrilateral inscribed in a circle, it's in a circle, opposite angles are supplementary. So this angle and this angle, they're not the same. I need to be very, very clear about that. They are supplementary. So angle K, if you add that angle plus the measure of that angle, there's two m's right there, don't get confused, it equals 180 degrees. Angle K is not congruent to angle M. Don't do that. Don't say they're equal. They're supplementary. Add these two together, it equals 180 degrees. Add these two together, measure of angle L plus the measure of angle N, it equals 180 degrees. Example 4. Last example, we'll finish. EX4. No center. Quadrilateral. Anybody making sounds out there? Anybody, like, you're watching this video in your bedroom, your door is shut, you're just trying to focus, and you know, you're just kind of taking care of things, and I don't know, your mom or dad walks by doing the laundry, and then just behind the door they hear, like, what is daughter or son doing? Find X. No sounds. No sounds. That's it, folks. That's it. Don't set these equal. They're not equal. If you have a quadrilateral, four-sided shape that's in a circle, these two angles add up to 180 degrees. 14x plus 8x plus 4 equals 180. Solve for x. We'll be done. One's at 22x. Subtract 4 on both sides. Equals 176. That's a 6 there. And if you divide both sides by 22, I am getting my phone calculator going, because if you remember, I left my graphing calculator at school. So frustrating. 176 divided by 22. Got it! X equals 8. Alright, done with the notes. Hopefully you stayed with me that whole time. Hopefully I didn't put you to sleep. Your homework. Page. I've got it. 727. Let's do 11 and 20. They go fast, folks. They go super fast. And 23 to 30. Once again, midnight. Make sure I get this assignment by midnight. You have yourself a good rest of the Monday. We won't see you tomorrow, Tuesday, and I'll jump back at you on Wednesday. See you guys.